At this very moment, a strange interstellar visitor is passing through our solar system at a speed of 60 kilometers per second. This object comes from a distant star system far beyond the edge of our own. Early observations suggest that it shows several unusual traits, from changes in brightness to motions that are difficult to explain. In just a few days, it will reach perihelion, the closest point to the Sun in its path. The big question for astronomers is simple: what will happen when that moment arrives? Today, we are looking at one of the most mysterious interstellar objects ever observed near our solar system, Comet 3I Atlas. It is the third interstellar object ever detected by humanity, and scientists are using every precious moment to study it before it leaves the solar system and disappears back into interstellar darkness. The story began on May 1, 2025, when the Atlas Survey Telescope in Chile detected a faint point of light moving quietly across the sky. At first, it seemed like an ordinary observation. But once astronomers calculated its trajectory, they realized this object was something very different. It was not orbiting the Sun, it was passing straight through our solar system. You can think of the solar system as a giant rotating structure where planets, asteroids, and comets generally move in the same overall direction, shaped by the Sun's gravity. But 3I Atlas is different. It is traveling the opposite way on a hyperbolic path, the kind of orbit associated with objects that come from outside the solar system. That alone would be remarkable, but there is more. The object is moving on a retrograde trajectory, meaning it is traveling against the direction followed by most bodies in the solar system. By late October, it will reach perihelion, passing through a region of space relatively close to the orbit of Mars. After that, the Sun's gravity will fling it back out into interstellar space, and we may never see it again. The real mystery deepened when scientists pointed the James Webb Space Telescope toward 3I Atlas. They expected the familiar signatures of a normal comet, including water ice, some carbon monoxide, and perhaps a little methane. Instead, they found something very different. Spectral analysis showed that the comet's coma appears to be dominated by carbon dioxide. The ratio of CO2 to water in 3I Atlas is far higher than what we see in any known comet from our own solar system. That opens up a major question about its true origin. Carbon dioxide-rich comets are not unheard of, but not at this level. It suggests that this object formed in an environment very different from the one that produced the comets we know. Its home star system may have been much colder, or the disk of material that formed its planets and icy bodies may have had a very unusual chemical makeup. The strangeness does not stop there. When astronomers measured the polarization of sunlight reflected by the comet, they found something rare. Polarization helps reveal how materials scatter light, and in this case, 3I Atlas showed one of the most unusual polarization signatures ever recorded. That suggests its dust particles may have a strange structure, composition, or outer coating. They could be unusually dark, porous, or covered by material, unlike what we normally find in our solar system. Some scientists are even considering the possibility that this comet represents a completely new type of interstellar object. If that is true, 3I Atlas may offer a rare glimpse into the chemistry of icy bodies formed around other stars. What makes the story even more fascinating is how the comet behaves near the Sun. Normally, when a comet gets closer to the Sun, heat causes its internal ice to vaporize, releasing gas and dust into space. That process creates a small thrust that can push the comet slightly off its original path, almost like a natural engine. But 3I Atlas seems to challenge that pattern. Even though it is clearly active and releasing gas and dust, its orbit remains extremely stable, following a purely gravitational path as if no extra force is acting on it at all. That has left astronomers puzzled. Are we seeing an unusual kind of material, or a physical process we do not yet understand? One possible explanation is that the comet is much denser or more massive than it appears. From a distance, it may look light and fluffy, but beneath the surface it could be a heavy, compact body. Another possibility is that its outgassing is mostly symmetrical, causing the forces to cancel each other out. Large dust grains could also reduce the overall thrust. With such unusual features, some people have naturally wondered whether 3I Atlas could be an alien object. Whenever humanity discovers something strange from deep space, speculation like that appears. It is an exciting idea, but science depends on evidence, not imagination. So far, everything we have seen points to 3I Atlas being a natural object. It may be strange, rare, and unlike anything we have observed before, but it still fits within the boundaries of physics as we understand them. If it were an artificial probe, we would expect signs such as unnatural radio signals, spectral features linked to manufactured materials, clear non-natural course corrections, or an unusually perfect shape. None of those signs have been observed. Its orbit still follows gravitational rules within current measurement limits. Its chemical composition may be unusual, but it remains consistent with natural formation. Its spectrum also shows no clear sign of artificial origin. In other words, 3I Atlas is not a message from a distant civilization. It is something arguably even more valuable. A rare fragment of another star system that gives us a direct look at the diversity of matter in interstellar space. Right now, telescopes around the world are tracking this visitor closely. The James Webb Space Telescope continues to study its light spectrum to better understand its chemistry, while ground-based observatories monitor its dust structure, reflectivity, and any subtle changes in activity. One of the most important goals is to measure isotope ratios, which may reveal deeper clues about the environment where the object formed. In a broader sense, 3I Atlas may only be the beginning of a new era in astronomy. Once the Vera Rubin Observatory becomes fully operational, our ability to detect interstellar visitors is expected to increase dramatically. Some estimates suggest we could find dozens of such objects every year. Each one would be a messenger from another planetary system, carrying chemical evidence from places humanity may never reach. It is incredible to think about the journey of 3I Atlas. Millions, perhaps even billions of years ago, some violent event in its home system may have thrown it out of a stable orbit. It could have been a planetary collision or a gravitational disturbance caused by a wandering world. Since then, it may have drifted through interstellar space like a frozen time capsule, preserving the original chemistry of the place where it was born. On that long journey, it may have passed through molecular clouds and crossed the outskirts of distant star systems before finally entering ours. Now we have only a short window to observe it. That gives us a rare chance to study the chemistry of a star system we have never seen, and to glimpse the astonishing variety of planetary systems spread across the Milky Way. The final question remains: what will happen when 3I Atlas reaches its closest point to the Sun? Will it behave like an ordinary comet, or will it surprise us once again with something entirely unexpected? Whatever the answer, 3I Atlas is a reminder that the universe is still full of mysteries, and that every piece of matter drifting between the stars may carry an ancient story waiting to be uncovered.